In this lesson, we're going to talk about percents. So first, let me just write out the word percent and break down what it means. So notice the first part of this word here we've already seen, the word per. Per is a way of kind of comparing two things, right? So when I say miles per hour, I'm comparing the amount of miles I can go in an hour. So that's the same usage of the word per here. And then cent, think of the word century. Cent means 100. So when we say percent, what we are meaning is per 100. So when I take something, for example, like 50%, and by the way, the symbol for percent is this symbol right here. So 50% is literally 50 per 100. Okay. Now you should already kind of have a sense that 50% is half of something. You've probably kind of understood that just from your everyday encounters with percentages. So, and with this definition, it makes perfect sense because, of course, you would reduce this fraction and find that 50% is half, right? 100%. What is 100%? Well, 100% is all of something, or one whole. Why? Because 100% means 100 per 100, which of course is just one whole, right? So hopefully that gives us an idea of what percents really represent. So it's how much you have out of 100. Okay. But what I want to do in the examples below here is convert some numbers that are not written as percents into percents. Okay. One of the really important things that we can learn how to do is convert between percents and decimal numbers, fractions, mixed numbers, and so on, and then also the other way around. So here we're going to take decimal numbers, fractions, mixed numbers, and convert them into percents. All right. And the technique we're going to use in this particular video is the same technique we used when doing unit conversion factors back in chapter 1. So we're going to use a unit conversion factor here to convert 0.65 into a percent. So the idea here is what we already saw up here, that 100% is the same as one whole. Well, if those are the same, then it should be okay for me to set up a unit conversion factor where we put 100% on top and 1 on bottom. Since they're the same, I'm just multiplying by 1. So I have not changed the value of 0.65. But now what I've done is I can multiply 0.65 by 100. That, of course, just moves the decimal point over 2 places. So I get 65, and now I have the symbol of the percent that's appeared. So what we get here is that 0.65 is equal to 65%. Now, to get an idea of why we would need to do this particular process is later on we're going to do lots of story problems that involve percents. And for the most part, when we're working with percents within a story problem, we're going to have them in their decimal or fraction form. But of course, when we give answers in percents, we want to give it in percent form. So it's going to be important to go back and forth between these two forms right here. All right, let's take a look at this example. The first thing I want you to notice is that we're going to express 2 and 1/3 as a percent. Now, if we look back up here once again, we know that 100% is equal to 1. And so since we have more than 1 in this number, we should expect to have a percentage that is more than 100%. And of course, this is possible. In some situations it doesn't make sense, but in many situations it does. So for example, if I give a test in a class and I offer extra credit, right, then it would be possible for students to score above 100% on that test. Okay, if we're talking about the growth of a company that just takes off overnight. It may grow by 200, 300, 400% over the year. So we can certainly go above 100%, even though it doesn't make sense in all situations. So we're going to expect to have a percent greater than 100% when we convert this. So first of all, we have 2 1/3. Now, if I'm going to use a unit conversion factor, I'm going to be multiplying. So I better turn this mixed number to an improper fraction. And then, again, we're trying to make a percent appear. So I go times 100% over 1. And let's see, 3 and 100 have nothing in common, so I can't reduce anything. So this is going to be 700 over 3%. Okay. Now we don't want to leave it like this. We want to express our answer as either a decimal or mixed number. So let's go ahead and divide 700 by 3. 3 goes into 7 twice. Get a remainder of 1, drop the 0. 3 goes into 10 3 times. Again, you get a remainder of 1, drop the 0. 3 times. And let's go ahead and, well, actually, before I add a decimal, right away we can see one acceptable way to express this answer, right? Because I'm to the end of my place values in 700, I can see that this is 233 1/3%. Right? So we can express it as a mixed number. It's also acceptable to express it as a decimal as long as that decimal is exact. So what you might do here is add another 0. 3 goes into 10, again, 3 times. And so see what's happening here? We're just getting this remainder of 1 repeating over and over. And you might remember from past experience that if you just have the same remainder repeating over and over, this number up here is just going to repeat over and over. And so remember, the way we express that is after the decimal point, once we determine that a digit will just repeat over and over forever and ever, we go ahead and just write that digit one time, put a bar over it, and express our percentage in that way. And either one of these is okay. What I do want you to watch out for, though, is if you are doing a problem on WAMAP, it might specifically say to express your answer as a mixed number, for example. And in that case, just pay attention to the instructions and obviously give this answer.